When etching a PCB, it helps to get the ferric chloride moving around the board using a thing called a stirrer. So I've got these Neodymium magnets or rare earth magnets, but I noticed that when you put them down on the table, they automatically turn to face north. Even if you turn them right round, they'll spin back like a compass. So they're so powerful they interact with the Earth's magnetic field to the degree where they'll actually move in free air. Normally with compasses you have to put them on like a point or in a liquid so they don't get too much resistance, but on this one you can actually use it on the tabletop to actually point to the north. So to create a stirrer, what I've done is I've taken one of these Neodymium magnets, I've put it inside some heat shrink sleeving, and once it's in the heat shrink sleeving in the middle, if you inject some hot glue in the end with a hot glue gun, it shrinks the sleeving around the magnet, and then do the same on the other side, and then just a little bit of that comes out the end, just wrap it around there, just because you want to try and make these waterproof so that when it's in the ferric chloride doesn't get to the magnet itself. So that's the whole point of it, and also it makes a shape where when it's spinning it actually stirs the liquid. So the next stage was to make a little stirring action with a motor, which I just had this motor for ages. And you can get some plastic gears off of eBay, or you can get them from some electronic suppliers as well, and probably even model shops. So I've got a few of those gears and I put them in between some old PCBs. I usually recycle my old strip board, taking components off and using it for something like this. So I geared the motor down so that when the motor spins, it actually spins another Neodymium magnet here where I've put some hot glue over the top of it. So when that spins, it'll be able to spin the stirrer in the ferric chloride. So in order to power that motor, I've built a circuit. So I've got a DC-DC converter, a boost converter, and I'm going to power it from a single cell lithium-ion battery. And so I'm going to create, I think it boosts up to about 7 volts. I'm going to use it at. And I've made this circuit which is just a 555 timer, and when it powers, when you press the button, it will power for the motor for the stirrer for the period that I want to actually stir the ferric chloride and etch the board, and then at the end it will change the colour of the LED from green to red and beep for a little while just to let me know that the timing's finished. So if I just take the battery and try and connect everything up, hopefully getting things the right way around. I haven't used polarized connectors. The motor shouldn't really matter which way around to get that, because it will just spin in the opposite direction if I get it the wrong way around. And then the boost converter, that's important to get that the right way around. Okay, so when I press the button, the motor starts spinning, the LED's green, and then I have the period of about 20 minutes. After 20 minutes the LED will go red and the motor will stop spinning. And I've got here some water, because if it was ferric chloride I was demonstrating with, you wouldn't be able to see the stirrer. And you can see the stirrer in there. I haven't got it quite over the device properly there yet, but there you go. I'll just see if I can move it a bit closer to the camera. And you can see that the stirrer rotates and disturbs what will be ferric chloride, and hopefully that should make the etching process a lot more efficient, a lot faster. So I'll go through the circuit diagram, even though it's a simple one. I've got an input voltage, it says 12 here, but really I think I'm putting in about 7 volts. I've got a capacitor across the input voltage, and that just smooths it out, because the boost converter I'm using causes issues with the circuit if you don't have a smoothing capacitor there. And then for the trigger of the first 555 timer, so I've got two 555 timers, or I think I'm using a 556. That's pulled up normally to high, and then there's a switch to start the timer which pulls it down to low. And it's just a monostable timer. It's got a big capacitor on the output, or on the timing circuit, a big resistor as well. And I think that's a maximum of about 14 minutes I think it provides. I've set it currently to 20 minutes, but hopefully I should be able to bring that down, because I haven't used the stirrer yet, but when I'm using the stirrer I should be able to bring the etching time down. I'm not heating the ferric chloride either, that's something else I could do. And then the output of that circuit goes to a transistor which will drive the motor. So if I scroll across the circuit, temporarily go all the way across. So the output here is where I drive the motor. So the signal comes along here, and so it drives the ground of the motor through that transistor. So that's the output of the first timer. And also the output also comes across here, and when it goes high, which is when it's actually timing, it has no effect on the trigger of this second 555 timer. It's when this first 555 timer, the output goes low at the end of the timing. Then what happens is I use this capacitor here and this resistor, and it just creates a low pulse for a period of time before this capacitor. Then when this capacitor is charged, it then goes back to a high pulse again because it blocks, because this resistor pulls the signal back up to high. And that's necessary. So this capacitor is crucial, because if you don't have that, then the output of the first timer is always low, and so when this monostable multivibrator over here comes to the end of its time, if the input signal is low, then it will just start another timing process. So you need this capacitor in here with this pull-up resistor just to create a low pulse to trigger the second one. That's the most complicated part of this second, or the most critical part of this 555 or 556 timer circuit. And then, yeah, like I say, the second 555 timer is just another monostable with a period, the period of which the buzzer is on for, and also the LED goes red because I've got a bicolor LED on the output. So the output of the first one, 555 timer, turns LED green whilst the timer process is in action, and then afterwards the second 555 timer turns the LED red for its period. Then the LED goes out in its idle state, and on the output I've actually got this adjusting circuit here, so I can actually adjust the output voltage or the output current, which is on the drive side. I've just got that set to the maximum at the minute. If you set that lower, then this transistor can get, if you're driving a lot of current, this transistor can get quite warm or even hot if you're driving lots of current. But I put this in the circuit just in case I want to be able to limit the current a bit on the output. And then on the output also I've got a smoothing capacitor here, and that's because if you've got an inductive load here, such as a motor, then it can create noise on the circuit, and that can cause problems as well.